This section is all about geometric sequences, all right? So in arithmetic sequences, to find how you get from one to the next one, you just take the second guy and subtract the first guy. Take the second one, subtract the first one, you get the common difference, and then you can see how you walk from one to the next. For geometric, it is a ratio, so you are going to be multiplying to get from one to the next. So to find your common ratio, which is what you're going to call this, not common difference, you divide. Take the second term, divide it with the first term, and you're going to see how you get from one term to the next. Now keep in mind, you can multiply by a fraction. So it's going from like 2 to 6 to 18 or whatever, you're multiplying by 3, then it's going up. But if it's going down, you could be dividing, but your common difference is actually going to be a fraction. So you always want your common difference to be in terms of what you would multiply to get there. Even if you look at it and you say, oh, I'm dividing by 2 to get there, you're going to say it's 1/2. So you're always going to put it in terms of a ratio. So is the given sequence geometric? So the first thing they just want to know is this geometric? And so in order to find this out, we are just going to look at the terms. All right, so we're going to say to go from 5 to 15, what do? Multiply by 3. Does that work here? Yes, it does. What about here? Yes, it does. So yes, this is geometric. And the common ratio is going to be 3. It's just that simple. What about here? 15 to 30. 15. You can multiply by 2, but what about here to here? No. There is something in common. What is it? What are they doing? They're adding 15. So this is an arithmetic. So this is not geometric. This is arithmetic. And you have a common difference here of 15. All right, so this is no. This guy is not geometric. This is arithmetic. All right? So that's really what you're looking for. You are looking for, is this multiplying to get from one to the other? And am I multiplying by the same thing? So if I were to just test this guy, I would say 30 divided by 15 gave me a 2, but 45 divided by 30 did not give me a 2. So this caused a problem. So that's all we're doing. We're just saying, hey, am I multiplying to get from one to the next? If so, is it the same thing? If that's the case, yes, I have a geometric. All right? That's the difference between geometric and arithmetic. Adding with arithmetic, multiplying with geometric. All right? Just like with arithmetic, there is a pattern with recursive and explicit. All right, so recursive is really simple. If I have my term in front of it, then to get to the next one, I multiply by my common ratio. Very simple, very simple. To get, though, the next terms, there is a pattern that happens. So if we look at the one that we just used, we had 5 and 15 and 45 and 135, right? And we could have kept going. I start with my first term. My first term is always a sub 1, all right? To get to my second term, I started with my a sub 1 and I multiplied by my r. That's pretty straightforward, right? Then to get to my third term, I multiplied by r and then by r again. Yes? And then to get to my fourth term, I took the term in front of it and I multiplied by r one more time. This is where we get this pattern right here. You start with your first term, and whatever term you want, you're going to take r to 1 power less, okay? So I started with my first term here. So this is my fourth term, right? 1, 2, 3, 4. To get to that, I started with my first term, and I did r to the third power. Why is that? Well, the first term isn't multiplied by r. So it's 1 less than the term that you're on. So this is where we get the explicit formula for a geometric sequence. We do the first term times your common ratio to a 1 power less than the term that you want. All right? Make sense? A reduced copy of a photograph. The actual length of the photograph is 10 inches. The smallest size the copier can make is 64% of the original. Find the length of the photograph after 5 reductions. 5 reductions, all right? So here's the thing. What is my first term here. Where do I start with this? I start at how many inches? 10 inches. So my a sub 1 here in this word problem is 10 inches, all right? Now, if I want 5 reductions, what term will I be on? This is the same as the other word problem. Yeah, I'll be on the 6th one, right? The first one is my original, and then I have 5 reductions after that. Does that make sense? So I'll actually be looking for my 6th term here. That's what I'm looking for. What is the 6th term if I have that many reductions? Your common ratio is the percentage that you are reducing it, right? If it reduces it, the smallest size is 64%, it's reducing by 36%. But if its smallest size is 64%, then my R here is 0.64. It's a hideous R, looks like a V. All right, my R here is 0.64, right? Make sense? So I could take 10 and I could multiply by 0.64 by 0.64 by 0.64 by 0.64. I could do that, right? Or if I set this up in explicit, I could say, well, the 6th term is going to be my first term times my R to the 6 minus 1, right? And I just fill that in. My 6th term is what I'm looking for. My first term is 10. My R is 0.64. 6 minus 1 is 5. And when I get that, I plug it in. They actually rounded to hundredths. 1.07 inches is how big it would be after that many reductions. About one. This check understanding 2, they want the 19th term. Now, if I said find the next 3 terms, I would say find your common ratio and then just multiply by it, right? But for the 19th term, I would say use your explicit formula, okay? So what you're going to do is you're going to use your first term, you're going to use your common ratio, and you're going to use your explicit formula for a geometric to find your 19th term. So try A and B there. The graphs of arithmetic and geometric sequences have different shapes. Arithmetics are linear. So when I did the explicit formula for this last one that we just did, a sub n equals, what was it, -3n plus 23, something like that, right? That should look familiar. That should look like mx plus b. I mean, right? Does that not look like an mx plus b formula? There's a reason. It actually forms a line. When you do this guy, which was what, 3 to the n minus 1, is that what it was? Was he times 3? So we had 11 times 3 to the n minus 1. This is an exponential, right? So you can see it curving like a parabola. There's a reason, okay? This is an exponential formula. So geometric's going to grow exponentially. As you saw, when you gave me the 19th term of the geometric one, it was this humongous number, right? Because it's growing exponentially by 3. So it's going to be just shooting up there. Whereas a linear is just going to be nice and steady, right? So your arithmetic are going to be a linear. They're just going to steadily grow, steadily shrink, whatever. Your other ones are going to shoot up one way or the other, depending on what's happening to it. It's going to be an exponential function. So then we get to geometric mean. We found arithmetic mean by legit adding and dividing, right? And so geometric mean we actually used in geometry. Y'all probably don't remember, but we did. Geometric mean is the square root of the products. So we use this when we compared pieces of like right triangles. The altitude compared to the base, that was the geometric mean. And you calculate, multiply the two and take the square root, and that was the geometric mean. And so that's exactly what it means here, the product of the numbers taken the square root of. So you can use the geometric mean to find the missing term of a geometric sequence. So if you look at this right here, physics, when a child swings without being pushed, air resistance causes the length of the arc of the swing to decrease geometrically. Find the missing arc length. All they want's the geometric mean. Of course, they gave us 6 1/8 just to be fun. If you multiply, of all things, if you multiply 8 times 6 1/8, it actually works out nicely because of that nice little denominator there, but you actually get 49 because 6 1/8 is 49 over 8 times 8 just gives you 49. You're going to get 7. Missing term 7. All right. And so she would have gone 8 feet and then 7 feet and then 6 and 8 feet in her little swing there. If it wants geometric mean though, how would I find it here? How would I find geometric mean? The guy in between those two. I would just say this times that. Yep. And you're going to get 40, by the way. So go ahead and try those two. All right, so you should have gotten, for this guy, 7.5. And for the next one, I don't have it in front of me. You should have gotten 378. Is he there? There we go.